Hey, this is Joe, and I'm just making this video to talk about the chemistry behind the atomic bomb. So, the core idea behind the atomic bomb is to assemble two subcritical masses to form a supercritical mass of the radioactive chemical fast enough that the reaction doesn't cause the bomb to fizzle when the two masses are apart. Now, you might ask, what is a critical mass? A critical mass is the smallest amount of matter required for nuclear fission. In an atomic bomb, a supercritical mass needs to be reached to make sure that the reaction is going to take place when you need it to, so the bomb doesn't fizzle. The measure of a critical mass is in the neutron multiplication factor, K, and it represents the average number of neutrons released to cause the next reaction, meaning when the two atoms hit each other and then a neutron and the neutrons break off, if more than one neutron on average breaks off, then the reaction is self-sufficient, meaning that the mass is critical. And if that average is greater than 1, then the mass is supercritical. So the bomb that was dropped on Hiroshima was called Little Boy, and it was made out of uranium-235. It had a gun-type detonator, which means that, like the diagram in the bottom right shows, there's a barrier separating two subcritical masses of the uranium-235 from combining, and when that barrier is removed, the two will come together to form a supercritical mass of that uranium-235, causing the chain reaction to occur and the explosion to take place. In Hiroshima's case, there were 141 pounds of 82.7% uranium, but only 2 of those pounds fissioned. So had even 20% of those pounds fissioned, the explosion could have been even more massive. In Hiroshima's case, it was the equivalent of 15 to 16,000 tons of TNT being exploded. Fat Man was the bomb that was dropped on Nagasaki, and it was a little bit more complex than the bomb that was dropped on Hiroshima. It had a core made of plutonium-239, but the detonator was implosion-based because plutonium, the neutrons come off faster than in the uranium, meaning that they had to combine the subcritical masses faster than with the uranium so that the bomb didn't fizzle. So the way that this detonator works is that there's a subcritical mass of plutonium in the middle of that diagram, and there are detonators on the outside of it, and when those detonators are set off, the explosion is so strong that the shock wave compresses the plutonium, and when that plutonium compresses, it gets smaller, making it more dense, so that a supercritical mass is formed out of that. And in the case of Nagasaki, only 2 out of the 13.6 pounds of the explosive fissioned, and it was the equivalent of 22,000 tons of TNT exploding. Thanks for watching. That's some of the chemistry behind the atomic bomb. If you have any questions, you can just ask me in class or in the halls or something.